Lesson is dealing with rational expressions, and I don't just mean this video, I mean this week's lesson is all rational expressions, which is basically just fractions with letters and numbers in it, and it can be a little confusing. So we're going to break this into 3 videos with hopefully a little bit smaller chunks that are a little easier to consume. So let's back up for a second and kind of do a little refresher in dealing with fractions. This whole lesson is going to be fractions, but they're going to have letters. So I want to back up for just a minute and review with whole numbers because that's a little bit easier to start. So this says 1 over 5 plus 3 over 5 equals 4 over 5. So remember, when you are dealing with fractions, you can only add when they have a common denominator or subtract. And when you are adding or subtracting fractions, you keep your denominator, it stays, and you just add or subtract your tops. So this is a true statement, and I think your textbook has things like, it's going to show you an example like this, and you have to write either correct or incorrect for some of the things. I've never actually seen this started off like this. I've never seen it taught like this, but we're going to go ahead and work our way through it because I think it will give you a good foundation to sort of understand some things later on. Now, the same rule applies when we have letters, and here's what happens. I've taught long enough to know that students see fractions first of all and they panic. Then you have another panic moment when there are variables, and then you put fractions and variables together and chaos ensues. So here's the thing, those rules don't change. Fraction rules stay the same. If I have numbers, I can only add when the denominators match. When I have letters, I can still only add when my denominators match. So on this second problem, my denominators are 5, so I can add. Here is where the dilemma hits. I can't actually do anything with 2 plus x. They aren't like terms. If you kind of remember back into Algebra 1 and probably pre-algebra, you're taught you could only add terms when they're the same type of term. They're called like terms. 2 and x are not like terms, which means this is as simple as I can get, which is not helpful in the reality of things because that's not any simpler. We don't still really know exactly what that means, but that's as far as I can go because I don't have like terms, okay? Now, I can work this from left to right, which is how our brains like to see it, but I can also work it backwards. I can break it up. So here I put it together, 2 plus x. Here, I'm going to break it apart. And so the problems that you're going to be given are going to be put together and or broken apart, and you're going to have to figure out if it is a correct statement, if it truly is equal to each other. So let's kind of jump in and look at our next piece. We're going to remember that I can take it apart or put it together when I'm adding. My numerator. If you notice on here, my denominator stays the same the whole way. Let's look at this another direction. So I can separate my numerator like we just did. I split that apart, but I cannot separate my denominator. Denominators have rules of their own. And one of those rules is when I have something stuck together with a plus sign in my denominator, I cannot separate it. So if I were given oh, sorry, my pen quit working. This does not equal this. 2 plus 1 is 3. And if I look at this as x plus 1, that's that. But the problem is, in the mathematical scheme of things, this denominator is 1 unit, and I cannot separate it. Okay, you can separate or you can split apart the numerator, but you cannot separate the denominator. So let's look at this one, and this is the type of problem that you're going to see. You're going to be given a term, and then you're going to have an equals to, and you're going to have 2 pieces of information, at least 2. You may have 3 or 4 depending on how big the first term is, and you have to decide if it is correct or incorrect. So remember, I can split up my top. I cannot split up my bottom. So let's look at our bottom first. X plus 1, x plus 1, x plus 1. They're not split up. They're together. So denominator rule fits. Let's look at my numerator. I have to end up with the value of 3. Is 2 plus 1 3? Yes, which means my numerator checks out. So my answer would simply be this is correct. Now again, this is kind of odd because there's not even a whole lot of math to be done here. We have to just sort of look at things and figure out if they are equivalent to each other. Here is where this gets tricky. And especially like my son who has dyslexia and dyspraxia falls apart here because that's a lot of mess written right there. That is a lot of x's, that is variables, it's coefficients, it's fractions, it's exponents, and it's a lot for us to sort of process. So we're going to look at our denominator first, and then we're going to look at our numerator. So remember, we cannot separate our denominators. The first thing I have to do is make sure my denominator has not been changed. And visually, I can look at this, x squared plus 4x plus 3, and across the way I have x squared plus 4x plus 3. So my denominator passes. Now remember, my numerator can be split up. X squared plus, watch those signs, 3x plus 7. It's the exact same fraction, it's just sort of pulled apart, kind of like when we used to do expanded notation. So this, my bottom follows the rules. My top is split apart and it gives me the same value. So this is a correct statement. The left side is equal to the right side. So we can separate the numerator when we're adding. Let's look at this one. Start by looking at our denominator. We cannot separate our denominator, and instantly I can look at this and say, well, this is all one term. Now I've split it into 1, 2, 3 terms, so I've separated my denominator, which means that fails the denominator test, which means this is an incorrect statement. My left side does not equal my right side. Now I could show you why. That would require creating a common denominator, and it would be a very long mess that we will get into later, but not today. So this one is incorrect because we cannot separate the denominator. All right, here's 4 practice problems that I would like for you to do, and you just have to figure out if they are correct or incorrect. One thing I want to remind you, especially on number, or not especially, but for number 4, that when I have a number over itself, it reduces down to 1. So just keep that in mind for number 4. Try these and then let's work them together. Okay, let's walk through these two. So the first one, start by checking our denominator. Is our denominator kept together? X minus 5, x minus 5, x, yep, check. Now, does the value on the top match left and right? My total value has to be 5. 3 plus 1 is 5, which means my top value is equal, which means this is correct. You don't even have to put Y on the homework. You just need to put correct or incorrect. And there's only a couple of these. But I will tell you this is correct because the bottom is not separate and the value on the top matches each other. They are equal to. Now let's look at our bottom one, number 2. Start by looking at your denominator. Is it equal? Is it the same on each side, or has it been taken apart? I have to have x minus 5, but here it's split apart. I cannot separate my denominator, so the answer to number 2 is incorrect. Let's look at number 3. Number 3 is kind of written backwards, but while that's kind of trippy on our brain, it's still kind of the same thing. And I can look at this 2 ways, but let's look at it the way we've been looking at it, but we're going to work it backwards. Is my denominator the same? X, X, X. Yes, denominator matches. Do my left and right values of my top match? Well, on the left, I have x plus 3. On the right, I have x plus 3, so they are equal to each other, which means number 3 is correct. My denominators match and my values on my top match. Now number 4, there's 3 steps here we have to process through each one to get to our final answer. And actually it's the same problem, it's just taking one extra step. My denominators match x, x, x. My top, x plus 3, x plus 3. Now here's the thing though. I can technically take this one step further because x over x, anything over itself is equal to 1, which means the value of this is equal to the value of this because x over x reduces to 1, and that is the same value as this, so this is correct. So this is a little bit odd way to do this, but just process through. My denominators cannot be separated. My tops can be as long as their values stay the same.